All right. So now that we have everybody set up, the rest of us are going to be members of the jury, and you're going to be using this box right here to determine whether or not Courtney Smith robs the bank. So when we are reading this script, there's going to be testimonies from each one of the 4 girls that we're going to use to fill in these boxes. The gist here is that the takeaway will be each one of these girls drives one of these color cars. And the person who is guilty was driving a specific color car. Okay? So, we're going to have to fill this in every time we learn a piece of information to cross people off the list. Put your phone up. All right, so every time you hear something that would let you know that person doesn't drive that color car, you're going to put an X in the box. So maybe Morgan says, I hate the color blue. Then you're going to put an X in the blue box. All right? When it's all said and done, every person drives a different color car. So if Caitlin drives a violet car, nobody else can drive a violet car. That's what this is telling us right here. And I'll make sure we slow down as we're reading to make sure that we all catch the information that we need to mark off. Yes?
The defense attorney approves of the defense or the DA?
The defense and the defense is defense attorney. DA is the... All right? Okay, so let's get started. Caleb?
All rise, the Honorable Judge Rainwater is presiding.
Please be seated. Mr. Defense Attorney, you may begin.
Good morning. Today you will hear the testimony from 4 girls, Country Smith, Morgan Button, Caitlin Ford, and Emma Street, as to why they are not the robber. The girls drive one of the following colors of car: violet, yellow, blue, and black, while one of them is the robber. You can prove through their statements that my client Courtney Smith is innocent.
Thank you. District Attorney?
Hello. The reason we are all here today is to prove that a defendant, Courtney Smith, robbed a bank in North America on Main Street. We will hear evidence that shows that Ms. Smith is the robber and should be convicted of this crime.
Mr. Defense Attorney, you may call your first witness.
Thanks. I call Courtney Smith. Please state your name for the court.
Courtney Smith.
Ms. Smith, you have been accused of robbing the bank on Main Street. Mr. Jones told the court earlier that the robber was seen in a black car.
My favorite colors are black and violet, and my car is one of these colors, but I was working at the time of the robbery.
Thank you, Mr. Smith.
Okay, so everybody hear what Courtney said. She said that her favorite colors are black and violet, and her car is one of those colors. So where should I put an X?
Yellow.
Okay. All right, Mr. District Attorney?
Oh, no questions, Your Honor.
Mr. Defense Attorney, you may call your second witness.
I would now like to call Ms. Morgan Button. Please state your name for the court. Ms. Morgan, please tell us why you are not the bank robber.
I would be caught in a yellow or violet car.
Thank you.
Everybody get that? Would not be caught in a yellow or violet car. Mr. District Attorney?
No questions, Your Honor.
Mr. Defense Attorney, you may call your third witness.
Defense calls Caitlin Ford. Please state your name for the court.
Caitlin Ford.
Ms. Ford, please tell us why you are not the bank robber.
The color of my car is one of my favorite colors, blue and yellow.
Your favorite colors are blue and yellow. So you think about what you should mark out.
Only you said to actually mark colors.
So now you're off the bat.
Thanks.
Mr. District Attorney?
No questions, Your Honor.
Mr. Defense Attorney, you may call your fourth witness.
Please call Emma Straight to the stand. Please state your name for the court.
Emma Strayed.
Ms. Straight, please tell us why you are not the bank robber.
First of all, I don't like black cars. They get too hot. Second, I would never buy a yellow or violet car.
So I don't like black cars, they get too hot. Second, I would never buy a yellow or violet car.
Thank you. I have nothing further.
Mr. District Attorney?
The prosecution rests.
Thank you. At this time, I would like the jury to deliberate and determine the verdict of Courtney Smith. Please take 5 to 10 minutes to determine your verdict. So, you should have enough information at this point to determine what color car one of the girls drive. And if that girl drives that color car, I can go put X's for everybody else on that color car because it says no one else drives that color car. So I want you to try and fill in the entire chart. I'll give you just a minute to do that.
Oh my god, it's Morgan. Oh my god, Morgan. How could you? Wow, it was Morgan. Morgan the bad word all along. It was Morgan. I have one too.
Oh, thank you. Okay, so let's go back over what we were told. Okay, so first we heard from Courtney. Courtney said her favorite colors were black and violet, and her car was one of those colors. So where did we put an X? Good. All right, and then we heard from Morgan. Morgan said she would not be caught in a yellow or violet car, so we put X's in. All right, and then we heard from Caitlin, who said that the color of her car was one of her favorite colors, blue and yellow, so we put X's in. Good. And then last we heard from Emma. Emma said she doesn't like black cars. And she would never buy a yellow or violet. So, we can tell now that Emma drives what color car? Which means these two girls can't drive blue, right? Okay, do we know what color car Caitlin drives then? And then that means Morgan is going to drive black, so Courtney drives violet. So our job was to determine whether or not Courtney was guilty. Is Courtney guilty? No, because she doesn't drive a black car. Good job. Okay, so we just explained why she was not guilty. They said that the guilty person drove a black car and Courtney did not drive a black car. What we just did was break down these statements that were given to us. All of these statements that were given are what we would call conditional statements. And those are just going to be statements that we draw conclusions from, exactly what we just did. So conditional statements is what we're going to be talking about today. All right, so before we start filling in any notes, anybody want to tell me what goes in that blank? Yeah, why? What's the pattern? We're dividing by 3. Very good. All right, anybody want to tell me what comes next in this sequence? FM. Do we need a hint on what the rule is here?
Yeah. Oh, it's the mindset.
Okay.
July.
Okay, so that one was a little bit harder. Okay. All right. What about this one? guesses what comes next?
S. That would be 2 more S's.
2 more S's, is that what you said? Okay, let's look.
Yeah, no.
Okay.
Thursday, Friday, Saturday.
All right, so this part is written on you guys' paper. So what we were just looking at was conditional statements. And conditional statements are just going to be predictions based on inductive reasoning. You should be writing this part in red under the words conditional statements. And write it down. Guys, we're not taking pictures of it, we're writing it down. Write it on your paper. Okay, do you need to sit closer? Yeah? Okay. Can one of you guys switch with her so she can see better? Alright, so conditional statements are predictions based on inductive reasoning, which is basically what we were just doing. We were just trying to draw some conclusions by recognizing patterns. Right? We were looking at those patterns, trying to figure out what's going to come next. Okay? Alright. If-then statements. That's what we got next. If-then statements are just a form of conditional statements. So there's a few different ways that it can be written. But if-then statements are going to be the ones that we use the most commonly in this class. So it's just a specific way that we write our sentence or our statement. An if-then statement or any conditional statement can be denoted by this right here. P and then the little arrow to Q. That little arrow just means implies. So P implies Q. Okay? P and Q can be anything. Maybe P is some type of problem or expression in math, and Q is your answer. If you have this math problem, you are implied to get this answer. It could also just be some kind of scenario. So it might be like, P is if I study for my test, and Q, the implied part, is that I will make a good grade on the test. Okay, so whatever comes first implies what follows. So they kind of go together. Okay. If it is written as an if-then statement, it will always include the hypothesis, which is our P, and the conclusion, which is the Q. Okay? And your hypothesis is always going to be after the word if. And your conclusion will always be after the word then. So if I was to give you an if-then statement, it would work like I was just explaining. If I study for my test, that's the hypothesis, then I will pass. I will do well. So we're going to start with some real simple examples just like that so that we can learn how to break them down into the hypothesis and the conclusion. So if it's not written as an if-then statement, it's not always going to be super clear which part is which. Okay? All right, so they have a couple of conditional statements written there on our paper. Okay? So the first conditional statement says, all panthers are cats. What they want us to do is try and rewrite that as an if-then statement. So it should say, if you fill in the hypothesis, then fill in the conclusion using those words. Right? You're just rewording it. So it might say, I did well on my tests because I studied. That could have been the original statement. But if I turned it into an if-then, I would say, if I study for my tests, then I did well. Right? So how could I rearrange these words into an if-then sentence? So take a second. can write it down or just think about it, and then in just a second I'm going to ask anybody to share what they came up with. All right, I saw somebody's hand go up. What would you rewrite it as?
If it's a panther, then it's a cat.
Exactly. Okay. And your words don't have to be exactly like mine, but if it's a panther, needs to be the hypothesis. The conclusion is that it's a cat. Right? So panther needs to be at the beginning, and cat at the end. Right? So this says if it's an animal. If the animal is a panther, then it's a cat. But that is exactly what he just said, slightly different word. All right. The other conditional statement they gave us says the sum of two odd integers is even. So we also want to rewrite that as an if then. Okay?
If two numbers are odd, when added together, then it is even.
Then it is even. Okay. So sum of two odd integers. He took the odd integers part and put it at the beginning with the if. Then their sum is even. So if two integers are odd, then their sum is even. So whenever we do an activity where you have to write your own statements, I'm not going to take off if it's not worded the exact way that mine is. What I'm looking for is that you have the correct information where the hypothesis goes, followed by the conclusion. Okay. If you're confused about where it splits, usually the sentence will split at the verb. Not always, but usually. You don't have to write that part down if you don't want to. All right, so next we've got counterexample. I think this is the very last thing on the front of y'all's page. Counterexample. It's just an example that will prove the hypothesis part of your sentence to be true, but the conclusion to be false. So, whenever you're having to prove or disprove a statement, whenever you're trying to come up with a counterexample, all you have to do is come up with one place where that would not be true. Right? So like on that last if-then sentence, we had if you add two odd integers together, then their sum is supposed to be even. So you would just be trying to think of any two numbers that are odd if we add together that they're not. Would be the counterexample. So that would prove that last part of the sentence to not be true. Okay? All right. And then if you will flip it over onto the back, what they ask us to do is underline the hypothesis of the statement and circle the conclusion. So all of these have something that should be underlined and something that should be circled. If you don't know what this symbol means right here, this means congruent. So same size, same shape. And then we know that equal means. Okay. So you determine which parts should be underlined and which parts should be circled. So take a second, look at problems 1 through 4 there, underline the hypothesis, circle the conclusion. A good way to think of that is basically what cannot happen or what could I not know without knowing the other part, right? The part that you have to know is going to have to be the hypothesis. Okay, so on number 1, when it says BW equals XY, implies that BW is congruent to XY. So on number 1, what part did you guys underline? Equals XY? Yeah, because this would be just like on the first notes we took, P implies Q, right? P is always our hypothesis, and Q is our conclusion, right? I wouldn't know if these two things are congruent if I wasn't already told that they were equal, right? I can't just know if something is congruent if I know nothing about the two. All right, kind of the same idea on number 2. It says K is the midpoint of JL if JK is equal to KL. So which part did we underline on that one? What part do we have to know first? Right, we have to know that these are equal in order to determine if we have a midpoint. Very good. All right, on number 3, n is greater than 8 if n is greater than 7. Which part do we have to know first? Right. Okay, and then number 4 says, I'll dive if you dive. So what has to happen first? You dive. Good. So just think a bit about what's going to have to happen first. I kind of gave away number 7 here already, but take a second and do the same on problems 5 through 8. We're underlining hypothesis, circling conclusion. So thinking about what has to happen for us to know the second thing. Okay, on number 5, what do we underline?
If A is B.
Right. This one is actually already written as an if-then statement, right? So it should be very clear which part is the hypothesis and which part is the conclusion. All right. What about on number 6?
If A plus equals B plus C.
All right. It's got to be, again, be that first part because it's an if-then statement. And then number 7, I kind of already accidentally had that pop up before we got into it. But he only sings when everyone makes an A. So if he is singing, that means they must have all made an A. And then the last one, number 8. What should we underline there? Very good. Okay. All right. So on problems 9 and 10, they want us to give a counterexample. So remember, our definition of counterexample is just something that would prove the last part to not be true. Okay? So on number 9, it says, if Rachel is 16 years old, then she has obtained her driver's license. So how could she be 16 and not have her driver's license? Is that possible? Never took her test, or maybe she took it and didn't pass, right? Any of those would work as reasons to why she wouldn't have her driver's license. So a counterexample would be either she hasn't taken the test, or maybe she didn't pass the test. Either one would work. Okay? Number 10 says if a number is divisible by 4, then it is also divisible by 6. Can we think of something that would make that not true? An example? All right. Any number that you can think of that you can divide by 4 but can't divide by 6. All right, we got lots of options. So, counterexamples are usually pretty easy to come up with because you just have to think of one scenario that would make it not true. And you're done. Okay? All right, and then now that we've kind of talked a little bit more about if-then statements, numbers 11 and 12 are going to give us the opportunity to practice one more time how to rewrite them as if-then statements. So number 11 says congruent segments are segments that have equal lengths. Okay. Okay, so does anybody want to share how they might rewrite that? So this one I could almost see you arguing it either way because congruent does mean same size and same shape, and that's also kind of what equal means, right? That they're the same. So you could write it as if segments are congruent, then those segments must have equal lengths, right? All right, number 12 says an equilateral triangle consists of 3 congruent angles and 3 equal sides. So, anybody want to share how they might rewrite that?
If it is an equilateral triangle, it has 3 congruent angles and 3 equal sides.
Perfect. All right, and then the very last portion of our notes talks about negation. So to negate, that's what usually means to like disagree or say no, right? So does everybody have their sentence written before I'll give you a second to finish writing their sentences. Okay. All right. So negation just means we are using the word not. We're going to begin a statement with it's not the case that, and then we continue on with our statement. So it's got to have that word not in it to be a negation. And it's denoted by this little line here. We had an argument earlier when I went over this, but what would we say that is called? I know it has a name. It's like a key on the keyboard.
Squiggle.
That's what I was calling it, a squiggle, but I know that's not what it's actually called. But that's what we'll draw in order to denote negation. Just like to denote that something is implied, we drew the arrow to it. This symbol means to negate. Okay. All right. And that is it for conditional statements.